Right. Good morning, good afternoon, good evening, wherever you are across the globe. Welcome to Math2P75. This is our last lecture. How is everybody? Are there any questions? Anything? Thank you, Matthew. Okay. Remember, I love your questions. You are welcome to ask questions throughout the lecture. The method you ask question is that you can ask your question in the chat area, or you can directly speak up, okay, by starting excuse me, okay. And you can also ask me questions through the email. When you email me, please be patient. It usually takes 2 business days, okay. So our last lecture today, I will start by saying some housekeeping stuff. First and foremost thing is our final exam. Make sure you check out the announcement on Sakai about final exam information. Final exam is on Saturday, July the 10th, from 7 p.m. to 9 p.m. on my lab under test quizzes. Okay, it covers all the course materials listed on the course outline, but with the focus on these chapters and sections. Okay, today I will go over those questions from those chapters and sections. Okay, so this is the very important item, our final exam. The final exam link will be available at 9:50. Okay, you cannot see the link, okay? At 9:50 on July the 10th, you see the link, okay? Make sure you have your calculator ready, Excel ready, sheet, textbook, the e-textbook, okay? Study notes, PowerPoint slides on hand. It is just this exam not only tests your knowledge about financial mathematics, but also test your proficiency. You need to complete 12 questions. I'm telling you, those 12 questions coming from those chapters and sections. You need to complete 12 questions in 2 hours. Okay, in 2 hours. Some students in the past give me 5 hours. I will do much, much better. I'm sorry. This is a 2-hour test, not 3 hours, not 5 hours. Maybe giving you 10 hours, you can get perfect, but that is not the case, okay? So make sure you not only know material, but know the material very, very well, okay? And you can work out each questions without hesitation. There is virtually no time to think. Okay, once you start the questions, all the questions you already see, either in the format of examples or lecture examples, lab questions. Okay, every question actually comes from the textbook. It just changed the numbers and the background information. Okay, so this is the final exam information. And on my lab side, this coming Friday, our last quiz is due, quiz 6. It is about chapter 16, okay? Our TA guide you through some questions from chapter 16 in today's lab. Hope you will practice more, okay? And today I'm also going 2 questions from chapter 16, okay? So this is some housekeeping stuff. And last item, remember every Wednesday I have office hours in the morning from 10 to 11 in the chat room. Okay, use these office hours. I'm here in my office hours. If the office hour does not suit you, you can always email me about specific questions. Again, please allow 2 business days to have your email answered. Okay. So I also want to take this opportunity to thank you so much for your participation in our last lecture. I hope you learned some skills in this course and do very well on the final exam. Okay, we just have a few days left to the final exam. Okay, please ask me questions, specific questions today, right now, or email me your questions. Okay. All right, so any questions? I also posted the practice final exam question here. If you go to my lab, you see practice final exam, it is not a count toward your final grade, but it is 2 hours. You can do this practice final exam many times. There are no limit. You can do 2 times, 5 times, 10 times, but each time it is just 2 hours. And each time the question number will be changed, okay? And also when you write our final exam, your question 1 is different from other student question 1. So the questions are randomized, okay? The numbers are also different, okay? So make sure you do your own work, okay? Today I'm also, how similar are the practice questions to the real exam? Very similar. The question is how similar the practice final exam to the real exam? Very similar, okay? So today I'm going to go, and also on the Sakai I just sent you, if you go to resources folder, so if you can download this practice final exam PDF file, because I'm going to go this file by question. This file just give you the answer. I will provide detailed solutions. Okay, a study tip for preparing for final exam. If I were you, I will make sure I do all these 12 questions from practice final by myself. If I am stuck on some questions, I will go over related textbook chapters examples. Okay, so start from those 12 questions. Okay, if you are not comfortable with some question, redo the example from the textbook. For example, this is the PDF file I posted on Sakai. I also send you email. If you can open this, as we go along, you can make notes. Okay, many people are using OneNote. You can open the PDF from OneNote, and you can write down, you can handwritten, you see, you can write down the notes, okay? All right, any questions? Okay, so you ready for all those 12 questions? For the 12 questions, I will go 11 questions. 1 question for chapter 8, section 4, demand loan. I will recommend you to watch my YouTube video. Okay, I will show you. There are 12 questions. I will go over 11 of them. Okay, 1 question I don't go over because I prepared YouTube video for chapter 8, section 4. So you go to YouTube, and then on the search bar, you type in my name, Pauline Fu, and then demand loan. Okay, there are 2 videos. 1 video is 16 minutes. The other video is 7 minutes. They're all about chapter 8, session 4. Okay. So for the demand loan, you watch those videos. If you have any questions, you go the textbook examples, demand loan, chapter 8, session 4. Okay. All right, so go back to the practice questions. You have this question. I just sent you email 1 hour ago. 1 hour ago, check your email, or you can find this PDF file on Sakai under resources, practice final. This is the question set I'm going to go over right now. Any questions on what we are going to do now? Any questions? All right, so you ready for this question? If you look at the question ID, you know this question comes from chapter 15, session 2. Okay, chapter 15, session 2. Chapter 15 is the bond price. Session 2, how to calculate bond purchase price. Okay. So a 25-year bond issue of amount 5,805.8 million and bearing interest 6.5% payable annually is sought to yield 6.2% compounded quarterly. What is the issue price of the bonds? That is the question. Okay, what is the issue price of the bonds? So remember, the price of the bonds has two components, two present value. One is what present value of this number. Okay, what is the present value of, this is the face value, future value. This is the future value. And the other part is what is the present value of monthly payment, PMT. You add these two present value, the result is the price of the bond. And what is PMT? PMT is the face value times bond rate 6.5%. Usually it is payable semi-annually, but this question annually. So you just times 6.5%. Okay, so there are two present value. You add these two present value, you get the bond price. Okay, and now the question is, how would you compute these two present value? You have many methods. Here I'm going to present two methods. One is Excel, the other is calculator. Okay, Excel and calculator. So I'm going to present calculator first. Where's my calculator? Okay. So now I'm going to calculate what is the present value of this number. Okay. So we need to set up the calculator. Now I have two decimals. Obviously, it's not enough. So I need at least 4 round all immediate values to 6 decimals. So I'm going to need 6 decimal places. Okay. So how do I set 6 decimals? Second, format, enter number 6, enter. Okay. Then second set, second quit. Now I have 6 decimals. Okay. So the first step, compute the present value of this bond. So second, PY is 1. Okay. And down arrow key, CY is 4 because it is compounded quarterly. CY is 4, enter. Then second, quit. Okay, so you set up PY, CY. Now enter the future value, 58. This is the future value. Okay. This is the, let me see here. If using the so this is the future value. Okay, future value. And then interest is 6.2. You enter 6.2 is IY. And this is 25-year bond. So compounded quarterly. So 25 times 4, N equal to 100. Okay. And 0 is PMT. And compute PV, present value. Okay, so this is you can add, eliminate the negative sign. Okay, so this is the present value of this amount. Next, you calculate the present value of PMT. So first, you have to calculate what is the PMT. It is this number. Okay, so I'm going to calculate 58 times 6.5%. It is 0.065. Okay, so PMT equal to oops, where's my calculator? 377,000. So you calculate PMT. What is the present value of this number? Okay, so I'm going second quit. So the PMT, for PMT, it is payable annually. Okay. So PY is 1, CY compound interest is quarterly, correct. And now you enter PMT 377,000, negative PMT. 0 is future value. 6.2 is interest. Okay. And term N, every year you receive 1 coupon once, okay, paid annually. So N equal to 25. Compute present value. Oops. 25 compute present value. Okay, now you get the present value of this PMT. Last step, you add these two together. There are two present value. That is the bond price. Okay. So this is a calculator method. If you want to use Excel, try to okay, for Excel, you need to calculate PMT first, and we already calculated PMT equal to 5800 6.5%. So this is PMT. And you also need to calculate equivalent rate of interest per payment period, P. Equivalent rate, remember what is P? P equal to 1 plus I. I is 6.2%, compounded totally, divided by 4, and then raised to power CY over PY. Okay, CY is 4, PY is 1, minus 1. This is the equivalent period. Okay, when you have PY not equal to CY, you need this P as interest. Okay, so this is P. And now compute the present value. Present value for this number. What is the present value for this number? Okay. In Excel, you type in PV. Okay, rate, this P. Okay, is the rate. NPER. NPER 25. Or in the calculator, I have to correct a mistake. The term is 25 for both present value. Okay. PMT is a 0. Neutral value is this one. Okay. So this is the present value. Okay. Another present value, you have to calculate what is the present value for PMT. What is the present value for PMT? Equal PV. Rate is this P. NPER 25. PMT is negative 377. Okay, the bond price is just add these two present value. Add these two present value is the bond price. You see, agree with this answer. Okay. So any questions? I'm going to write down the calculator steps. Okay. Calculator, you need to set PY is 1, CY is 4. And the term N is 25, not 100. Okay, I correct for both situations. Okay. So this is a bond price. Any questions? Check my message. Okay. I just found the message because, sorry, London, I just saw your message. How is PMT 377000? Okay, the question is, how did you get PMT 377,000? Because the face value is 58,000,000. Because the face value is, okay, so by definition, PMT is the every year you received a payment. So use 5.8 times 6.5%, you get 377,000. Thank you, Linda. Okay, yeah. Okay, any other questions? All right, so next question. This question comes from chapter 12, session 5. Chapter 12, session 5. If a page is accumulated 62,000 by saving 60 every month for 6 years, what is nominal annual rate of interest compounded semi-annually has been earned? So the question asks you IY. Okay, what is IY? That is the question. Okay, to answer that question, we use calculator. Okay, second, quit to clear anything. Now set PY, number of payment, save $60 every month. So PY equal to 12. 1 year you save 12 months. Okay, so CY, interest is compounded semi-annually. CY equal to 2. Okay, and then PMT is 60. PMT is 60. Accumulated means this is the value. Accumulated to. So you just type in this. Second PY. PY is 12. Enter. Down arrow key. CY is 2. Enter. Second quit. Okay. Now enter 6,200. This is the future value, FV. Okay. 60 is a negative PMT. Okay. 0 is the present value as a precaution to clear any previous entries. 6 years. 1 year has 12 months. 6 years, 72 months. So 72 is term N. Final step, compute IY. See, you get 11.88. Okay. So this is chapter 12, session 5. Okay. Next, this comes from chapter 10, session 2. Okay. But you can use the compound interest applications. The question is, what nominal rate of interest will money double itself in 6 years? In 6 years, 5 months, if compounded monthly. Okay. Again, the question asks you, what is IY? This is the question. What is IY? Money double. You have to assume. Diana, can you show us on Excel? Some of us do not have the calculator to complete question 2. Excel read. You better have a calculator. I can show you the the Excel, okay, question 2 on Excel. Move back. So going back, okay, thank you, London, for your question. Now I'm going to go back to question question 2, okay, to show Excel method. For Excel, the nominal rate of interest. So you use rate function, RATE rate, okay, NTER for 6 years, NTER 2, PMT -60, PV present value 0, future value 62,000. Okay. Hold on, this is a remember this number you get is actually P. Okay, it is P. P equal to this number. P equal to this number. And then you have to use, oops, hold on. If you check my previous video, I gave you detailed example. Once you calculate P, you use this formula. This is P, okay? P equal to 0.9663. And once you get this P, you use this formula. P equal to 1 plus I raised to power C. C in this case is 2 over 12, then minus 1. You already got P. P is here. Okay, one equation you solve for I. Okay, you solve for I. Okay, this is the Excel method. Okay. So return back to question 3. What nominal rate will money double itself in 6 years? In 6 years, 5 months. So let's say you have $1. Okay, you have $1 today. In 6 years and 5 months, the money doubled. Double means you have $2 after 6 years, 5 months. After 6 years, 5 months. Okay. The question is, what is the rate? That is the question. Okay. So again, our time limit, I will just show you the calculator method because sometimes the calculator is actually very efficient. Okay. So I go to second quit. So you need to set up PY because it is compounded monthly. Okay. So PY is 12. Enter. Down arrow key. CY is 12. Second quit. Okay. So this is present value is $1. Future value is $2. Okay. And the question, and then term N. Okay. So 6 years, 5 months equal to how many months? So 6 years is 72 months. 72 months plus 5 months equal to 77 months. Okay, so that is term N, 77. 77 term N. Okay, and then 0 PMT. Final step, compute IY. Oops. Arrow. So I'm going to, maybe I press some button wrong. I will redo it because I got error. Okay, PY is 12, CY, okay, second equation, okay, so 1 is present value, okay. Oh, when you have both present value and future value at the same time, one of them you have to enter negative, okay. So this 1 is present value, 2 is negative future value, okay. And then 0 is PMT. 77 is term N compute. Oops, I stuck. Compute IY. Okay, you get 10.85. 1061. Okay, so make sure PV and FV, one of them is negative when you enter the calculator, okay? And PMT is 0. All right. So this is question 3. Question 4. Okay, this question 4. This question, this is the question I refer to those two YouTube. Chapter 8, Session 4. Check out my YouTube, okay? Those two questions. Okay. And make sure you truly understand why each step goes deeply understand each step, because the test question will be different, but the principle remain the same. Okay, for chapter 8, session 4, the principle will be the same for the 2 videos I created, but you need to have deep understanding of each step in those videos, because the question is not directly similar to those videos. Okay, so I warn you. Okay, oops. So this is this question. Next question is chapter 11, session 4. Chapter 11, session 4. A contract can be fulfilled by making an immediate payment of 20,900 or equal payments at the end of each month for 4 years. What is the size of monthly payment if interest is compounded monthly? 10.8% compounded monthly. Okay, what is the size of a monthly payment? So in this question, first you have make sure your calculator is at the end mode, and then PY equal to PY equal to what is PY? You make payment each month. So 1 year has 12 months, and CY compounded monthly. So CY is 12. And this number is the present value, PV, and this is IY. And the question is, what is PMT? That is the question. What is PMT? Okay. So second equation, set up PY. So second PY is 12. Down arrow, okay, CY is 12. Second quit. And then 20,900. This is PV, present value. And then for 4 years, 4 years have 48 months. So 48 is term N. Interest is 10.8. 10.8 is IY. Do not forget 0 is FV. Compute PMT. Okay, you get this number. Okay. So if you want to use Excel to calculate this one, you just use PMT function in Excel. All right, any questions? Okay, thank you, Benjamin, for your hint for the Excel read function. Next question. Question 6 is chapter 16, session 3. Ask you to calculate internal rate of return. Internal rate of return. Okay. So this one, I'm going to first use the Excel to set up data, and then I will use both Excel and the calculator for this one. So pull out my Excel. So I'm going to try to adjust my computer so that going to maybe need another new worksheet. All right, so this question, install a new chair lift. Construction is estimated to require an immediate outlay for 240,000. Okay, and the life of the lift is estimated to be 15 years with a salvage value of 80,000. Cost of cleaning and grooming new area is expected to be 35,000 each year for the first 3 years. Okay, for the first 3 years. Okay, and then the benefit, the net cash flow is 38,000 for each of the first 5 years and 60,000 for each of the following 10 years. Okay. Calculate the internal rate of return. Okay. So now I'm going to, let's say, the immediate outlay is negative 240,000. And this is immediate. But the cost of cleaning happened in the first 3 years. The first 3 years, each year you will spend 35,000. Each year you will spend 35,000. Okay. Maybe let me draw a timeline first. Okay. is now. This is year 1, 2, 3, 4, 5 until year 15. Okay, so now you have money in, money out. So let me put money out first. Doesn't matter. Okay, doesn't matter. Money in, money out. Now immediate money out is, I will omit, the unit is 1,000. I will omit those zero. Okay, I'll just use negative 240. Okay, and then the first 3 years, you also occurred 35. Okay, so you have negative 35 here, negative 35, negative 35. This is the first 3 years. Okay, actually the cost, the 35, negative 35 happened from now. Okay, this is negative 35, 1, 2, 3. You count here. Okay, see. I will maybe write down here. This is the first 3 years. You have negative 35. And then net cash flow is 38 for the first 5 years. Okay, so first 5 years, you have 38 here, 38 here, 38, 38, 38. This is the first 5 years. Okay, cash flow, net cash inflows. Okay, and then the rest of the 10 years is 60. So year 5, year 6, year 7. So this is 60, 60 until 60 here. And on the last year, year 15, you have a salvage value 80. So you also have 80 here on year 15, salvage value. Okay, so now once you have this diagram, so right now I'm going to use Excel. Okay, now I'm going to use Excel. So right now, the immediate outflow, the cost is negative 240, negative 35 right now. So I better put 0, 0, 0. Oops. So negative 240, 0, 0, 0, 35, 0, 0, 0. This is right now. Okay. And now, from year 1, year 2, until year 15, what happened for those years until year 15 here. Okay. So look at this timeline. This is right now. You have these two numbers right now. And in year 1, what happened in year 1? So 38 money in, 35 money out. So the net effect for year 1, it is just 3,000. Okay, 3,000. This is year 1. I will pause for a moment. This is year 1. Okay, and year 2, you have 38 money in, 35 money out. The net effect is 3,000. Oops. Missed one zero. Year 2 is 3,000. Okay. And now year 3 is 38. Okay, year 3 is 38,000. Okay, and this happened for year 3, year 4, year 5. See diagram, okay? 3, 4, 5, okay? And then for 60,000, from 60,000 until year 15. But last year, you have to add the salvage value, 80,000. So 60 plus 80, 140,000. Okay. Any questions? Can I make suggestion? We do not have break. We keep on going. We are finished early. Would that work for everyone? No break. Keep on going. So just one video recording. Would that work? Can somebody give me some response? Hello. You wanna break after this question, or you want to continue? Keep on going. Thank you, Teresa. Thank you, Hamza. Okay, so we keep on going, okay? So just one video recording, but we are finished early, okay? All right, so, all right. Once you set up the number in this format, and the next one is very easy, okay? Internal rate of return equal IRR, okay? IRR, and then select from B1 to B16. Okay, and make sure you have, this is 12%, but the answer is 12.5 because you need to know your Excel. You need to increase decimal places. See, when you increase your decimal places, you get the correct answer. Just adjust decimal places and read instructions carefully. Round to the nearest tens. There will no adjustment for rounding problem. Okay, so read instruction carefully. This is a financial mathematics demand accuracy. Okay. All right, so this is Excel. And once you set up this in Excel, and it is easy to use calculator, cash flow, okay, cash flow here. Oops. Try to adjust my computer so that you see the original question, the diagram, the calculator, and the Excel. All right. Okay. Maybe put a calculator here. Okay. This time you see all the information. All right. Cash flow. Okay. So you calculate the CF button. Start with CF. After CF, listen up. You have to press second clear work regardless. Always do this. Always first CF and then second clear work, this button here. And now enter, okay, 275,000. This is negative. Okay, so enter. Down arrow key. Okay, C means cash flow. 1. The first cash flow we have 3,000. 3,000. Okay, enter. Hey, did I enter? Oh no, this is this one. It should be 3,000. I entered one extra 0. 3,000. Okay, enter. Yeah, I entered correct. So 3,000. I have 6 decimals. Okay. So this number, then down arrow key. F represents frequency. How many times this number occur? 2 times. See, 3,000 occurred 2 times. You type in 2, enter. Then down arrow key. Next is 38,000. 38,000. Oops, no. Next is 38,000. So enter. Then down arrow key. How many times this number occurred? 3. 38,000 occurred 3 times. So 3. Enter. Down arrow key. Next is 60,000. 60,000. Enter. Down arrow key. How many 60,000 happened? 9, not 10. Okay? You count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, enter. The next is 140,000. 140,000. Okay, enter. Down arrow key. This number occurred only once, so frequency is 1. Okay, and once you finished enter the numbers, the question asks you to calculate what? IRR. Okay, you press the IRR button here, IRR, and then compute. Okay, so 12.48, exactly the same as our Excel, 12.48, but the answer asks you keep 1 digital decimal, so the answer is 12.5. Okay. All right, so this is question 7, 6. So I have to write down something. The other method, you go to press CF, okay, and then second, clear work, CLR, WORK, the bottom left corner. After that, you enter CF0 is negative 275,000, etc., etc. Okay. All right. So question 7. Question 7. This question is from chapter 13, session 5. Okay. Pharma manufacturing is considering a medical process that is expected to reduce its annual cost. Every year, you reduce annual cost by 50,000. The question is, what is the maximum amount of money that should be invested for the process to be economically feasible? If interest is 8.45 compounded quarterly. Okay, so the question asks you, this is perpetuity property. Okay, so the question asks you, what is the present value? That is the present value. Okay, and in this question, we have PY. Okay, this is a reduced cost annually. PY is 1. CY compounded quarterly. CY is 4. So if you have PY not equal to CY, you need to use formula PV equal to PMT over P. Present value for perpetuity equal to PMT. Normally it is PMT over I, but since you have PY not equal to CY, so you use PMT equal to divided by P. What is P? P equal to 1 plus I raised to power CY over PY minus 1. Okay, so you need to calculate P first. Okay, I is 8.45. CY is 4. PY is 1. minus 1. Okay. Is just 5000 divided. Okay, so this is the final step. Okay. Is frozen. Did anyone else freezing? What is freezing? You cannot see my video? Let me check. Oh. Can anyone, the video and the sound just came back to me. Thank you, Benjamin. Thank you so much. So hope everyone is okay. Okay, thank you, Benjamin. Okay, thank you, Angela, for Angela Teresa, London, for raise those questions. So now is okay, right? Okay. So this is a question 7. Question 8. Chapter 12, Section 2, net present value. Okay. Net present value. Right. And for this question, again, we need to use Excel to arrange data. Okay. So I'm going to, so this question is from, which one? This question, I'm going to use a new worksheet. And the next question. Question 8, chapter 16, session 2. Okay, chapter 16, session 2. Just double check. Okay. All right. So read questions. Then a company to make decision about expanding its production facilities. Research indicates that the desired expansion would require an immediate outlay of 70,000. Okay, so immediate outlay 1,000. Maybe and an outlay of further 60,000 in 3 years. Okay, so maybe I'll draw a diagram. This is now, This is year 1, 2, 3, 4, etc. So now you have money in, money out, negative 70. I will omit. The unit is 1,000. Okay. And then in year 3, you have outlay 60,000. So this is year 3. Year 3, you have 60,000. The net cash returns from year 1 to year 6, 22. And then from year 7 to year 11 is 11. Okay. The unit is in 1,000. Okay. And the question asks you, what is net present value? That is the question. Okay. So based on this diagram, you put data in Excel format. So right now it is negative 70,000. And then what happened for year 1, year 2 until year 11? Okay. So in year 1, see year 1, you have 22,000. Year 2, you have 22,000 positive cash flow. Year 3, what happened in year 3? You have positive 22. And then you have negative 60. Negative 60. So the net effect is negative 38 in year 3. In year 3. Okay. From year 4, year 5, year 6, you have 22,000 each. So year 4, year 5, year 6. And then year 7 to year 11, you have 11,000. Okay. And once you have this data, you just use NPV function, NPV, net present value. And the question given the rate of return is 12%. 12%. And then value. Value, you have to use this year 1 until last year as value. And then the plus the immediate outlay. So when you use NPV function, you always follow this format. You have to add the immediate outflow. The data range from year 1. Okay. So this is the answer. This is percentage. So you format the cells. Format the cells. Use number. How many decimals we want? Maybe usually we keep 4 decimals. So I'm going to keep 4 decimals. Okay, but the question asks you round final answer to nearest dollar. So the final answer is 2,167. 67. Okay, to nearest dollar. Okay. So again, no adjustment will be made for rounding problem. Read instructions carefully. This is financial mathematics, and it demands accuracy. So this is Excel. And how do you use calculator? In calculator, you follow exactly similar as the cash flow, but you press NPV button. Where is my calculator? So for calculator, you follow exactly cash flow method. Instead of press IRR button, you press NPV button. That's it. Okay, you get NPV. So this is this question. And the next one. This one. Chapter 14, Session 2. In Session 2. Question 9. A loan of 16,000 with interest 9% compounded monthly is paid in 6 years by equal payments made at the end of each 6 months. 6 months. What is the size of periodic payment? The question is, what is PMT? Okay, that is the question. What is PMT? Construct amortization schedule showing the last 3 payments. Okay. Question C, what is the total paid and the total interest? Okay, so let's do question 1 first. Question A. Okay. Try to find my calculator. It is here. So second quit, a loan. This is PV. This is IY. In 6 years, so term N equal to equal payment at the end of each 6 months. Okay, so 6 times 2 equal to 12. That is term N. And PY is 2 because you make payment each 6 months. CY, interest compounded monthly, CY is 12. Okay, CY is 12. All right. Second, PY is 2. Enter. Down arrow key. CY is 12. Enter. Second, quit. Okay. Now enter present value 16,000. This is PV. 9 is IY. 12 term N. 12 term N. Do not forget 0FV. Then compute PMT. Okay. So compare my answer with this answer. Exactly the same. Okay, so this is a question A. Now, question B. Question B. Strongly suggest you use calculator. Okay. Excel, you could use Excel, but you have to start with payment 2, payment 3 until the last 3 payments. The calculator, you can start with any payment. Okay. So we have total 12 payments. The last 3 payments is payment 10, payment 11, payment 12. Okay, this is the last 3 payments. So payment number, here you type in 10, 11, 12. So in payment 10, what is amount paid? Okay, and amount paid It is just the PMT. Okay, it's just the PMT we calculated. 1763. Read the question. The final answer, nearest cent. Nearest cent means 2 decimals. Again, read the instruction carefully, okay? And the interest paid, okay? Principal paid, outstanding balance. So how do you figure out those numbers? Calculator, okay? How? By quick second amortization button, okay? Watch. Second amortization button, okay? Second amortization button. Maybe I get out here to re-show you. So second AMORT button here, amortization. And then P1 equal to 10 because you are dealing with the 10th payment. Payment number is 10. Okay. So you type in 10, enter, down arrow key, P2, enter 10, enter, and then down arrow key, you have this balance. Okay, so this balance is here, this number, you type in here, 3297. Round all immediately 6 decimals, so I need more decimals. That's immediate. Okay, the final answer needs 2 decimals. Immediate need 6 decimals. So this is outstanding balance after 10th payment. Okay, and then you push down arrow key. Principal paid is this amount. Principal paid. And down arrow key again. Interest paid. All right, interest paid. So this is payment number 10. Okay, and then you use down arrow key. Use down arrow key until you see P1. You type in 11 means payment 11. Enter. Down arrow key. P2 payment 11. Enter. Down arrow key. Oops. I have the arrow. Second amortization. Second amortization. See, instead of 11, I type in 111. That is the problem. Cost of. So payment 111. Enter. Down arrow key. PY equal to 11. And down arrow key. So balance 11. So you have this balance. Okay, you enter here. Okay. Okay, I omit decimal, you continue. And then you have principal here. To save some time, I just enter the whole number. You need to read the requirement, okay? Down arrow, okay, interest. Okay. Amount paid, each time the amount paid is the same. Okay, so you keep on going. You go up, you enter P1 equal to 12, enter, down arrow key, P2 equal to 12, enter, and down arrow key, you get this for, this is 0, correct. Okay, and then down arrow key, principal. Down arrow key. To save some time, I just omit decimal. You need to read instructions, okay? So this is a question B. Okay. And question C, what is the total paid? Okay, total paid. Each payment you make this. Total paid is each time you make this payment. How many payment? Times 12. That is total paid. Okay. And what is the total interest? Use present value. 16,000 minus total paid. That is the interest. Okay. So any questions? Right. So this is question 9. Question 10. Question 10. Chapter 14, section 3. Sign all brands of 28,800 at the end of every 6 months from a retirement fund of 55,000. The fund is earned 5% compounded annually. How many payments will receive? So what is term N? That is the question. Question B, what is the size of final payment? Okay. Obviously, this 28 is PMT. Okay. Every 6 months, so PY equal to 2. Interest compounded semi-annually, CY equal to 2. And this number is present value. Okay, you calculate term N. Term N. So second quit. Second PY is 2. Enter. Down arrow key, CY is, hold on, second PY is 2. Enter. CY is 2. Second quit. 28,800 negative PMT. Okay. And then 50,000 present value. 0 is FV. 5 is interest. Compute N. Okay, so you got 27 point. Round to nearest whole number. When you have this kind of problem, you have to round it to 28, not 27. Even this 3 is smaller than 5, you have to round up. Okay, for the term N problem. Now, question B, what is the size of final payment? There are 3 major different methods to calculate final payment. Retrospective method, prospective method, etc. Here I'm going to use an easiest one, calculator. Okay, so once you calculated A, the calculator already have basic information. Okay, and then you go to second amortization button. Click second amortization. Okay, the final payment is happened in the 28th payment. So P1 equal to 28, not 18, 28, no. P1 28, okay, enter. Down arrow key, P2 28, enter. Okay. The P1, P2, actually the last payment. And then you click down arrow key. Okay. You have this balance 1800. Point, okay, 216. Okay. So after you press second mortgage, you get the balance here. And this indicates you have overpayment because it is negative number. Okay. Usually each time you make this payment, you receive this payment. Okay. So the last payment you are going to receive is just this negative. This number plus 28,800. So it is $999. Is the last payment. Okay. So this is question 10. Chapter 15, section 4. Bond price. Bond price. Use the method of average, found the approximate yield rate. The bond is redeemed at par, face value, okay, coupon rate, time to mature, market quotation. The question asks you what is the yield rate? That is the question. And it specifies the method of average. Okay, so you have to use, I will show you the formula. So this is the method you are going to use. So first we calculate the I, use average income per interest payment interval over average book value. So what is average book value? It is the average of quoted price and redemption price. And what is the average income per interest payment interval? You use total interest payments minus plus. If you have premium, you minus premium. If you have discount, plus discount, then our number of interest payment interval. So this is the formula. Okay, so first I'm going to calculate what is the total interest payment. Okay, or maybe calculate discount or premium. So let's go back to the question. This quoted price is less than 100. Quoted price less than 100. So you have discount. Discount of what? 2.625. You use 100 minus 97.375. So this is the discount. So every $100, you have 2.625 discount. Okay. So every $100 you have $2.625 discount. Now I have 30 $100. So this is the same as 30. Then the unit is 100. Okay, so the discount is, how to calculate discount? Using 100 minus 97.375, this number times 30. So equal to 2.625 times 30. Okay, and the result is 78.25. So this is the discount. Okay, and then you figure out what is the total interest payment. Total interest payment. So total interest payment. So semi-annually. Okay. So face value 3,000. Coupon rate times 9% compounded semi-annually divided by 2. Okay. And this is each time you receive this. But I ask you total, each time you receive this, how many times you received? Let me see. Time to mature 5 years. Every 6 months, you receive payment. So 5 years is 10. You receive 10 payments. The coupon is paid out every 6 months. Okay. So this number is total interest payment. Okay. So now, calculate the average book value. Average book value, okay, equal to quoted price, average book value. So face value plus what is that one called? It is quoted price plus redemption price. Okay. So quoted price is this is quoted price times 30. Okay, and plus redemption price. This is the average book price, and you get and now use the formula I showed you. Okay, I continue here. Okay, I continue here. That question. Continue here. I equal to average income per interest payment interval. So maybe before I put I will calculate average income per interest payment interval. So what is average income per interest payment interval, per interest payment. Okay, so what is the average income per interest payment interval? Okay, so this based on the formula. On the bottom, you have a number of interest payment interval. So 10. Total you received 10 interest, 10. Okay. On the top, you use total interest payments minus or plus discount. So total interest is here, 1,350. Total interest plus discount. Discount is 78. Okay, so this is average income per interest payment. I will not use this area to and this number I don't have this number. I have to figure the average. So I'm going to use Excel quickly to do it. Okay, this one. So now I have to use E-sum plus 142. Okay. So now you calculate I. So I equal to our average book price so this equal to 0.04825.8. This is I. Okay. And this is I. Okay. This number. Okay. Not this number. So you get this number here. So times 2, I times 2, you get 0.0965. Okay. Carefully. The question already gave you percentage. So you do not type in 0.0965 because the percentage is already given here. So this kind of mistake will not be adjusted, okay? So make sure you pay attention to detail. Okay. All right. So last question. Question 12. A new forklift. By the way, the last question comes from chapter 13, session 3. If the new forklift is purchased, month's end payment 650 would start in 2 years and continue for 5 years. Interest for the first 2 years is charged at So there are two periods. One is 2 years, the other is 5 years. So for the first 2 years, interest is 6.18 compounded annually. The question asks you, what is the monthly compounded rate for the payment period? So what is IY here for this payment period, for the 5-year period? That is the question. Okay, monthly compound interest rate. And given what? A new can be purchased at a cost of monthly end payment starting 2 years. So in 5 years period, PMT 650. And this equipment is 28. So 28, this is the present value here. Okay, cost, this one. And then you make payment 650 in after 2 years. Okay, this payment lasts for 5 years. What is interest for this period here? From here to here. That is the question. So there are two steps. Step 1, calculate this value here, the future value for this 28,000. And this future value becomes present value for the annuity. This future value at this point becomes present value of annuity. Okay, so now you have present value here, you have payment, you have 5 years, you calculate IY. Okay, and this is step 1. Let's calculate future value at this point. What is the future value at this point? Okay. So interest is compounded annually. So in step C1, 28 is PV. So I'm going to show you the calculator, okay, to quickly go through this one here. So second equate, PY is 1, enter. CY is 1, enter. Second equate, and then 28,000. 28,000, that is the present value. 0 is the PMT. 6.18 is IY. 2 is term N. Compute FV. Okay, so FV equal to 31. So this number becomes present value of this annuity. Okay, and in this annuity, PY equal to 12 because monthly payment. Okay, PY equal to 12. Monthly composite, and this is the present value of annuity. So the interest rate. So this value this number our store in number 1. Okay, later on I'll use this number. So now I will do step 2, the annuity. So first I will set PY CY. See PY12, CY12. So second PY12, enter. Down arrow key, CY12, enter. Okay, second, quit. Okay, now enter present value. So I'm going to recall this number. This number is present value. This is present value. Okay, and PMT 650. 650 is negative PMT. 0 is FV. Okay, and term N for this N that is number. All right. So any questions? It is a long lecture. The video and sound just came back to me. Okay. Any questions? So I'm going to stop recording. Stop recording. Stop recording.